In the first part of the Mega Mart store scenario, we took the data and created this handsome network, which is describing essentially the renovation of the store by moving various areas into other areas to make room. Okay, now wait. In this particular segment, what we'll do is we will work on the other parts of that scenario, which, if you take a look, require more than just a picture of the network. Okay, for example, suppose Mega Mart starts on this project immediately to finish as soon as possible. How much time will be required to complete this project? Uh-oh. What we had from last time, or essentially part A of that scenario, was a picture of the tasks. Now we need to do some computations. In order to answer that question, we're going to need to find the early start, early finish times of each of Mega Mart's renovation tasks. So the first thing I'm doing is starting with just a little bit of setup. Here I am subdividing each of the symbols that represents a task in this project by turning it into 2 rows and 2 columns. The left-hand column being rather narrow. That's just a helpful format. Okay, now speaking of setup, you know what we need? We've got the network from last time, that's great. We need, though, the duration data concerning each one of these tasks from the, right, here's the original problem statement. You know, I was drawing all over it. Right, each one of these tasks, like A, requires a certain amount of time. I want to copy that information now onto this network. Okay, for instance, moving the clothing out of the clothing area will take 3 days. I'm just noting that on the network. B, renovating the clothing area will take 4 days. I'm just copying it over from the problem. Let's see, returning the clothing to the clothing area will take 2 days. D is down here. D will take 5 days. E will take 4 days. F will take 1 day. G will take 3 days. G, I have to be careful. I locate the right numbers by the right letters. G will take 3 days. H will take 6 days. H is here. Okay, renovating the electronics area. I will take 2 days. I is right there, so I'll note that. J will take 3 days according to our data. Oh, J's down here at the bottom. 3. K will take 4 days. 4. And L will take 3 days. 3. Okay, now that's all just set up. Now it is time to do some actual analysis. We want to answer the question about the completion time by finding the early start, early finish times. For these tasks, you find early start, early finish times by beginning at the starting node, noting each activity that is attached to the starting node, so to speak, and noting that the early start times for each of those tasks is, for a fact, 0. Because 0 is right now on a number line, and that's what it means by these being attached to the start. If you wanted to, at the earliest, you could start on these right now. Okay, so in the case of moving the clothing, 0 plus 3, that means the earliest that could possibly be done is 3 days from now, because it's 3 days worth of work. If you started on moving the housewares right now, 0 plus 5, right, the earliest that you'd be finished with that is in 5 days. Now we want to work our way through the network towards the finish. Because I'm looking back up here at the top, and I'm noticing that, okay, renovating the clothing area cannot start until we have moved all the clothing out of the area. I'm just looking at the network here. We will have moved the clothing at the earliest 3 days from now, so pass the number over. That is the early start time for B, renovation of that area. Now 3 plus 4 is 7. That means the earliest we could possibly finish with that particular task is in 7 days. And you can see the arithmetic I'm using. Early finish equals early start plus task time. It's just logic. Okay, now you can't move the electronics or move the clothing back until you're done with the renovation. The earliest we'll be done with that renovation is in 7 days, so pass that number forward. That could start at the earliest in 7 days, and this could start at the earliest in 7 days. Now the arithmetic, 7 plus 3 is 10. The early finish time for task G is 10. 7 plus 2 is 9. The early finish time for task C is 9. Well, as long as I'm working along this path, I might as well keep going. Okay, so I come across H. H is renovate the electronics area. Now I'm just looking at the network. H cannot start until G and C are finished. That's what this illustration means. G will finish at the earliest 10 days from now. C will finish at the earliest 9 days from now. Therefore, what is the absolute earliest I could possibly start on this? Always choose the larger. Okay, that means 10 days from now at the earliest I could start that renovation. 10 plus 6 is 16. The earliest I could finish that renovation is in 16 days. And what we just practiced, that decision between the 9 and 10, remember, is known as the early start time rule. The early start time of any activity is equal to the largest of the early finish times that immediately precede it. Trace the arrows back. Okay, anyway, keep going. All right, now I is waiting on H, so you can pass the number over. I could start at the earliest 16 days from now. 16 plus 2, the early finish time for the task called I is 18 days from now. All right, now down here, the bottom over, who's not done yet? Okay, renovation of housewares is waiting on the moving of housewares out of that area, so you can pass the number over. That means that it could start at the earliest 5 days from now. 5 plus 4, it could finish at the earliest 9 days from now. When it's finished, both these other tasks, F and J, are free to start. 9 plus 1, F, the early finish time is 10. 9 plus 3, J, the early finish time is 12. And here's another chance to practice the early start time rule. You can't start renovating the foodstuff area until it's empty, which means that F and J are both finished. F could finish at the earliest in 10 days. J could finish at the earliest in 12 days. You have to pick the larger because it's waiting on both of them. So it could start at the earliest in 12 days. 12 plus 4 means it could finish at the earliest in 16 days. L is waiting on K to finish, so it could start at the earliest in 16 days. 16 plus 3, that means the early finish time for the task called L is 19 days. Those are the early start, early finish times for Megamart. Now, the question we were working on asked about the completion time, right? How do you find the completion time? Now that we have this, go to the finish node. Go to the finish node. We'll zoom in here a bit, right? And look at every activity that is attached to the finish node. Moving the electronics back in place and moving the foodstuffs back into place are apparently the two things that are finished up last in this project. Electronics could be moved back as early as 18 days from now. Foodstuffs could be moved back as early as 19 days from now. What is the overall completion time of the project if you want to get done as soon as possible? Again, you have to pick the larger. You're waiting on them both to get done. Oh, the larger is 19. That's the answer to that question. 19 days. If they want to get done as soon as possible, then if they start right now, 19 days is as soon as they could get done with the whole thing, with the project. Oh, all right. What else are they asking about this project? What is the critical path through this project? All right. We know there's 4 paths through this project. We can see that, but which one's the critical path? Now we have to find the late start, late finish times. That's the most efficient way to find the critical path. Okay, late start, late finish times. You find late start, late finish times by beginning at the finishing node, working your way back towards the starting node. It's kind of the opposite or the reflection of what we just did. Now, you begin at the finish node with that fact that we just obtained for the question before, that fact that they could get done in 19 days. We make that their deadline. We say, fine, therefore, Megamart needs to get done in 19 days. Oh, therefore, look at who is attached to the finish node. The very latest we will tolerate them being finished is 19 days. That automatically becomes their late finish times. All right, so the late finish time for I is 19 days. That's the latest it could finish without delaying the project. Now 19 minus 2 means the latest that we could start it is 17 days from now. That's just logic. Versus down here, 19 minus 3, the latest we could afford to start on moving foodstuffs back is 16 days from now. If we start any later than that, we're going to not make our 19-day deadline. So you can see that that is just also just logic. I'm determining a late start time by taking the late finish time and just subtracting out the task time. Oh, in essence, now what we're going to be doing is we're going to be kind of like backing up in time, backing up through the network. All right, now we need to keep going because we've got to do this for each one of the tasks. Now I'm looking back up here. Let's see, move electronics back. The latest it could start is 17 days from now without causing delays. It cannot start until H is finished. That's what the network means here. Therefore, pass it back. That must be H's deadline. At the latest, it'd have to finish in 17 days without creating problems. 17 minus 6, now it's just the arithmetic. That means at the latest, it has to start 11 days from now. Well, we might as well just keep going with this chain here. It has to start at the latest 11 days from now, but it can't start until G and C are finished. That becomes their deadlines. At the latest, they must finish each of them in 11 days. Now, in the case of G, 11 minus 3 is what, 8? The late start time for G is 8. Whereas for C, 11 minus 2 is 9. It could start as late as 9 days from now and not cause any problems. Now we're still backing up. We get to B. Oh, now B, maybe we should take a little bit slower here, because G and C, both C and G, are waiting on B to finish, right? That's what that means. G has to start 8 days from now at the latest. C has to start 9 days from now at the latest. If we don't meet that, then we're going to wreck the deadline. Therefore, they're both waiting on B to finish before they start. What is the absolute latest that B can finish and not create problems? Now we pick the smaller. It would have to finish 8 days from now at the latest, because if it didn't, it would mess up G. Okay, and then 8 minus 4, that means it has to start at the latest 4 days from now. And that is known as the late finish time rule. What we just did in general is the late finish time for an activity is equal to the, now notice it's the smallest this time, the smallest of all late start times that immediately follow it. Okay, now right here, only one last one to do right there. Oh, okay, B cannot start until A finishes. So you can just pass that number over. That means that A has to finish at the latest 4 days from now. 4 minus 3. You could wait as late as 1 day from now before you start moving the clothing, and you'd still get all this done in 19 days. Well, theoretically anyway. All right, now we're not done until we've done all of them, and we haven't done these here, so let's back up to here again. Let's see, L cannot start until K finishes. L has to start at the latest 16 days from now, so to pass the number back, that's the deadline for K. It has to finish 16 days from now. 16 minus 4 is 12. That means its late start time is 12. It can't start until these two things finish, so that becomes their deadlines, 12. And 12. Now in the case of F, 12 minus 1, its late start time is 11. Whereas in the case of J, 12 minus 3, its late start time is 9. Oh, and then here we get into another situation where we need to remember the late finish time rule, because F and J can't start until E finishes. F has to start at the latest in 11 days. J has to start at the latest in 9 days. We pick the smaller of the two so as to not create delays. E has to finish in 9 days. 9 minus 4 means that at the latest, E has to start in 5 days. Okay, and E can't start until D finishes, so you can just pass that number back. D's going to have to finish at the latest in 5 days. And 5 minus 5 means the late start time for task D is 0. And I'm really glad to see that, because by the time I work my way all the way back, at least one of the activities that's attached to the starting node, the late start time needs to be 0. Because if that's not true, then I must have messed up some arithmetic elsewhere on my way towards the starting node. Okay, but no, D, 0. Good, good, good. Now, what was the question? The question was, what's the critical path through this network? And we remember the critical path is a set of all activities with 0 slack. And we remember that slack is the difference between, for instance, the late start time and the early start time, or the late finish time and the early finish time. Either one will get you the same answer. Oh, which means that actually, since we're looking at the network with its timings, you can see the critical path, because the critical path activities are the ones in which the timing matches. Early start and early finish, late start and late finish are exactly the same set of numbers. You see it? It's all along and through here. I'm highlighting the activities in which early start, early finish, and late start, late finish are the same numbers. Now I want to check that that's a path. A path is any rational route from start to finish. Do these things actually connect? Well, yeah. And then you go to there, yeah. And then I'm just following the arrows. Yep, those are connected, and then that's connected. Oh, good. Good, good, good. Because that's the critical path. Let's see, it's all along the bottom of the network. It is, just to answer the question, what's that? D, E, and then that is J, and then that is K and L. There you go, the critical path through the network. D, E, J, K, L. Now, next question. What is the slack in activity C? Oh, well, we were just saying, what is slack? It is, for instance, the difference between the late start and the early start, or the late finish and the early finish. Should say late finish, early finish. Either one of these should get you the same answer. If it doesn't, you've made a mistake. So it's asking about C. We just need to retrieve that information for C. For instance, where's C? Oh, C's right here, right in here. Okay, the late start time is 9. The early start time is 7. The late start time is 9. The early start time is 7. There's your answer right there, and that's in days. The slack in activity C is 2 days. You'd get the same answer if you used late finish and early finish. Okay, that one's done. Next, assume the project is started immediately. Okay, what is the soonest activity H could possibly be started from now? All right, so what's actually being asked for here? It's H, but what? The soonest activity H could possibly be started is, by definition, the early start time of H. That's all that this question is asking, is what is the early start time of H? Well, let's retrieve it. Where's H? H, right here. Early start, right there, 10. 10 days from now. We start it right now. The earliest we'll be starting on H is 10 days from now. Okay, one last question. Assuming the project is started immediately. Yes, okay, right now. What is the latest that Megamart can finish returning housewares to its newly renovated area without creating any delay in the overall project completion time? Okay, what is the latest? It's asking for one of the L timings, so to speak. Can finish. It's asking for a late finish time. A late finish time of who? It's giving us the description, returning housewares to its newly renovated area. Oh, you just got to find that description on the original table. Returning housewares to newly renovated area. That's F. Not a mystery anymore. The late finish time of F. Just got to find it. What's the latest we would be finishing? There's F right here, returning housewares, moving them back. Late finish 12. 12 days from now. We started immediately, we started right now. The earliest we could be finished with that particular task is 12 days from now.